Hello everybody, welcome to Chapter 3. In Chapter 3 we are dealing with projectile motion. And in Chapter 3 there are no new formulas. We're just going to apply the formulas that we learned in Chapter 2 specifically to projectile motion. And we're working with a specific acceleration in Chapter 3, that's acceleration due to gravity. And if you look over here, the acceleration due to gravity, what your book refers to as g, is negative 9.8 meters per second squared. First off, it's negative because it's always pulling it downward. And oftentimes people will round it to 10, that's fine, but sometimes they drop the negatives. I want you to keep in mind that it's always negative and use negative in your calculations. I also like to refer to it as a vertical acceleration, or acceleration in a vertical direction. Reason being, in Chapter 3, the main crux of it is to separate your horizontal and vertical motion. In other words, a horizontal velocity has no bearing on a vertical drop, or vice versa. They're independent of each other. So oftentimes we're going to be working with distances and the three different distance formulas that I gave you back in Chapter 2. And if you recall, the first one, v equals vt, that's when there's no acceleration and it's traveling with a constant velocity. The second one, 1/2 at squared, that's when you have an acceleration starting from rest. Third one, the v sub ot plus 1/2 at squared, it's acceleration not starting from rest. So we're going to utilize those formulas in 4 different types of problems. And I'm going to jump into the first type right now. Say, for instance, we are trying to find the height of a building, and we just have an object, we're suspending it over the building, and we simply drop it. We time it, and we know it takes 1.1 seconds for the object to hit the ground. The only other quantity we know that is given is the acceleration due to gravity, and I'm going to round up to negative 10 meters per second squared. But also, considering that I dropped the object, I didn't throw it down, didn't throw it up, or anything like that, since we're dropping it, that's free fall, the initial velocity, in this case in the vertical direction, is going to be 0. So, if I'm asking how tall the building is, we have, starting from rest, acceleration, we're going to use the 1/2 at squared. So we start with the formula, d equals 1/2 at squared. So that distance is 1/2 gravity, which is negative 10 meters per second squared, times our time of 1.1 seconds squared. So we just type it into our calculator. And remember, we use 1/2 as 0.5. So we have 0.5 times negative 10 times 1.1 squared. I get negative 6.05. That'll be in meters. And you may be thinking, how can you have a negative distance? Well, it's more of a displacement in the sense that the ball landed, or the object I should say landed, 6.05 meters below from where it started. So in essence, that negative 0.605 meters is showing negative, or 6.05 meters, again, below where it started. That's why it's negative. Mathematically it's negative because gravity is negative, and that's what caused that number to be negative. But in the application, it's keeping in mind that 6.05 meters below where we started. Because what you have to think about doing here is creating an XY axis right at the edge of the building. So the edge of the building is our origin, and we're just holding it up and dropping it straight down. And it lands down here on the ground. So we're looking for that displacement technically, but we're using a distance formula to get it. And that's the first of the 4 problem types. In the next videos, I'll be introducing the other 4.